Good morning, afternoon, depending on when you're hearing this. We're looking at polynomials. Our objective today is to classify and write polynomials in standard form and evaluate polynomial expressions. The evaluation part should be easy, so I'm not going to really have much notes on that. You'll see it in the assignment. But the classifying and writing is what we're really going to work on. And our big question for today is, why do you think we need to know about polynomial characteristics? Why are we doing this instead of just jumping right into the adding, subtracting, and multiplying that we're going to do a little bit later? So be prepared for that. Also, as an added bonus, if you can, on a separate sheet of paper, after you've done all these notes, write a monomial in the power of, let's see here, let me double check this. Write a monomial that can be constant or a monomial with a variable. The variable has to be x, and it can be raised to any power between 1 and 4. So you could have something like 3x to the third power, or 10x to the fourth power, something like that. Have that on a separate sheet of paper. Have that for a special idea for an assignment for tomorrow. Okay? If you have it before class starts and show it to me before class, you can get 5 points added to your next quiz. Anyways, let's look at the next part of this. Alright, so the first thing we need to do is we need to first learn some definitions and learn some ideas. So we're going to start off here with a monomial. A monomial is a number, a variable, or the product of numbers and variables with whole number exponents. For example, you could say 5 is a monomial, or x, or negative 7x to the negative 7xy, or 1/2 x to the fourth. So all of those are examples of monomials. There's 4 different examples there. Each one of these is a separate thing that we're identifying here and saying that those are considered monomials. They could be a number, a variable, or the product of a number and variables. Non-examples would be like this. Things that we wouldn't classify as monomials. Negative 0.3 to the raised to times x raised to the negative 2 power. Or 2 over x to the third power. Here, because we have a negative exponent, we want whole numbers, which means positive exponents. Here, well, actually not because of that exponent, but because of the division, because we said product. So kind of keep that in mind for when we're looking at this. Okay, so the degree of a monomial is the sum of the exponents of the variables. So here we're saying that when we look at this, we do not include the coefficient. So we're not including something like this negative 2 with the exponent. We're only looking at the exponents of the variables, and that looks like now 3. So here we're looking at the 2 and the 4 to determine the degree of the monomial. And it says the sum of, so that means we need to add them. So 2 plus 4 is 6. So that means the degree of this monomial is 6. Here's another example. 4x, oops, actually I'm going to show it to you like this. What if I just gave you 4? Okay, do you see a variable? No, but you could always add a variable saying x to the 0, or any variable that you wanted. So that means then the degree of this is 0. Okay, one more example, 8y. Okay, do you see an exponent? No, but we always presume if there is no exponent on a variable, then it has an exponent of 1, so that means the degree is 1. Again, if you have any questions, write them down so you can ask me in the next class. Alright? Okay, so here this looks like a little bit, so you might have to pause me if you need to. Now let's look at what is a polynomial. A polynomial is basically a monomial, or the sum and difference of monomials. And a lot of times, instead of saying monomials, we'll just call them terms. So you're going to start hearing that word more often, terms. The degree of the polynomial is the degree of the term with the greatest degree. So for example, I look at this, the 4x minus 18x to the fifth. The degree of the monomial or term, that is the first one, which is 4x, is 1. But the degree of the second one, which is negative 18x to the fifth, or minus 18x to the fifth, just the 18x to the fifth, is 5. Okay? These two monomials are separated by minus. Keep in mind that. So when you separate these, so this thing has two terms like that. Now, the degree of this polynomial is 5 because the one with the greatest degree was 5. Alright, so here's another example. We're going to do 0.5x squared y plus 0.25 xy plus 0.75. Okay, the degree of the first one is 3 because 2 and 1 for the x and the y is 3. The degree for the second term is 2 because 1 and 1 makes 2. The third one, the 0.75, has no degree or 0 because there's no variables with it. Okay, so the degree of the whole polynomial is 3 because that is the degree of the term that has the greatest degree. And I'll use DOP for a degree of polynomial rather than write out the whole degree of polynomial. Alright, so let's talk about standard form. Standard form is writing a polynomial in order from greatest to least degree. Okay, so you see that example at the top, that is in order from greatest to least degree. Okay, here's an example of a polynomial. It's not in standard form, so you need to rewrite it in standard form. So we're going to move the highest degree is negative 4x cubed. Notice that minus stayed with the 4x cubed, stayed with its term. Then next would be, let's see, I've got a 3, then I've got a 2, so x squared plus the 20x minus, or no, I'm sorry, plus 2. Now, that means the degree of this whole polynomial is 3 because that's when you put it in standard form, you can easily find it. The degree would be the one that's right there in the front. And also we create what is called a leading coefficient. That would be the coefficient that is in the very front. So when you put it in standard form, the coefficient that is in the very front becomes your leading coefficient. And in this case, that is negative 4. Okay, I'm going to give you this table. I'm not going to actually write it out slowly, so I'll just give it to you all at once. Sometimes we can call polynomials based on their degree and the number of terms they have and give them a special name. So first off, let's look at the different degrees. If your degree is 0, you have a constant. If your degree is 1, it's linear, 2 is quadratic, 3 is cubic, 4 is quartic, 5 is quintic, 6, 7, 8, anything higher I'll say just to the 6th degree or the 7th degree or something like that. Okay, so if you look, there's some different examples of constant, linear, quadratic, cubic, quartic, and quintic type polynomials. Now, for the names, based on the terms. Based on the terms, if it has one term, we already know that's a monomial. 2 terms is a binomial. 3 terms is a trinomial, and 4 or more, we'll go ahead and say polynomial. So how do we classify this and give it a name? Well, let's look at this. You can see these answers here, but let's go backwards a little bit and do this. Let's say you have this example. Okay, in this example, it says 5x minus 6. I can see it has a degree of 1, and it is 2 terms. So I would write degree of the polynomial is 1 because the first coefficient, or the first term, has a degree of 1, and that there are 2 terms. So if I put that together, and the 2 terms are 5x and 6. If I put that together, based on the degree, I would call that a linear. Based on the terms, it would be a binomial. So this is a linear binomial. Something that you might want to make sure you have with you on during quiz or test with these notes on a note card. Y squared plus y plus 2 has a degree of 2. It has 3 terms, so this would be considered a cubic quadratic, or quadratic trinomial. I don't know why I was saying cubic. Yes, a quadratic trinomial. Again, based on the degree, based on the terms. Notice the degree name is coming first. Alright, next example. X cubed plus 3x squared minus 4x plus 1. Okay, so that means, plus 11. That means the degree of this polynomial is 3. It has 4 terms. So based on the degree, I would say this is a cubic, and because of the terms, polynomial. Okay, hopefully that should be fairly easy. If you do have any questions, let me know. This, again, we'll do some more questions with evaluations, but that's really just about substituting some numbers in place of the variables. So that's really nothing that's difficult. Again, do not forget about what I said about that extra little thing for 5 points. If you have to, go back to the beginning to hear it. Beyond that, I will see you when I see you, and hopefully you will have these notes. Thank you very much.